Okay. Okay, so just a quick revision. Tell me what are organic compounds? You're muted.
Carbon containing compounds.
Yes, any compound which contains carbon in them. But again, some exceptional cases. Some compounds, though they contain carbon, we don't group them under organic compounds. Can you tell me some example?
Carbon monoxide.
Okay.
That's the only one I know.
Okay, carbon dioxide and hydrogen carbonate. Okay. So we have learned it.
Okay.
You can't say that's the only one you know. You should know it. Okay, they won't question you in the paper again, but okay. So when it comes to organic compounds, carbon containing compounds. Now, last time you said organic compounds are like natural stuff, right? Now, when it comes to chemistry, don't go with that definition. That's the normal thing what we do, like what we know when it comes to all these organic foods, organic cream. I don't know if we have creams. Yeah, right? Cosmetics or any food. We get that thing in our head like something, or like even organic fertilizer, something all natural. But chemistry, the definition, go with carbon containing compounds, okay? Don't use the word don't go with that natural thing. Next, can you tell me some examples of organic compounds in a syllabus? Or anything.
Um,
Like all the
Carbolic
alkane. Huh?
acids.
What dear?
Is it carboxylic acids? I don't know how
Ah,
to say
yes,
that word.
carboxylic acids. Good. Carboxylic acids. They have carbon in them, right? Those group of compounds, like any compound which contains C double bond O, OH group in them, okay? And then it can have anything like this. So all the carboxylic acids is one group of example of organic compounds. And then what about alkanes?
Uh,
Alkanes are also examples, okay? Like they contain
yeah, and
carbon.
alcohol.
Alcohol, good, because they have carbon in them. And then alkanes, alkenes, alcohols, carboxylic acids, and we'll study something called esters. So all those compounds or group of compounds can come under organic compounds. And then we have hydrocarbons. What are hydrocarbons?
Hydrocarbons are compounds that only contain hydrogen and carbon.
Okay, and what is the simplest hydrocarbon?
CH4, 4.
Yeah, CH4, and then it is an alkane, okay? Alkanes form the simplest hydrocarbons. Okay, now when we see about, so that's it about the introduction. And then can you tell me what is, so we had different types of formulas, right? We had empirical formula, molecular formula, and in the structural formula, it was two types. What is it?
Displayed and condensed.
Condensed. So empirical formula shows the uh, simplified ratio, right, of the atoms
Yeah.
present in an element, and then molecular formula shows the exact number of atoms or elements present in a compound. And then we have, so can a compound have the same empirical and molecular formula?
No.
Now what about CH4? If the molecular formula
CH4,
is
yeah.
CH4, yes, the
CH4, yeah.
empirical formula is also the same. Okay. Now, if it's something like C2H2, then it should be CH, the empirical formula for this. Okay. So, some compounds, they can have the same molecular formula and the same empirical formula. Okay. Now, displayed and condensed formula. What is displayed and condensed? The difference.
Condensed is a formula, like in a formula version where it shows in each branch, like how many carbons and how many hydrogens, like CH3, CH3, CH2, CH3. While it's displayed is like showing all the bonds in between carbon and hydrogens.
Yeah, okay. So displayed formula is written by showing all the carbon-carbon single bonds, or like all the bonds, okay? Carbon-hydrogen single bonds also. And then condensed formula, writing the formula of a compound without showing the bonds. With showing the bonds and without showing. If you just mention that in your definition, that's okay. And then we looked at naming compounds. So naming compounds, we can name two types, like mainly just two types, with branch and without branch, okay? They can have branches or without. Now we'll just go with an example with branch. So see, what is this compound? How do we name it? If all these are hydrogens.
Uh, does that mean that's a double bond?
Is this a double bond?
No,
Single, right?
no, no,
Carbon-carbon bonds.
because one of the hydrogens was in there. It's C3H8.
Okay, dear, the name.
It's propane.
Yeah,
Propane.
propane, right? Because three carbons is prop, and then because it's an alkane, it ends with N. Okay, now if it is a double bond here, then
Then it's propene.
okay, now I should know the carbon number, right? So 1, 2, 3. I can also write as prop 1 in. Okay, or propene is okay because it's in the first position. If it's somewhere here, again it goes as what? Just
Prop
think this
one.
again, prop 1 in, okay, because I should go with the lowest number. I should number my carbon chain such that the functional group gets the lowest number, okay? And then if I have something like this, now this is a branch.
That will be
All these are hydrogens.
one. Uh, Methyl. Uh, But. One in. N.
1-methyl butane. Okay,
Yeah.
now is it 1-methyl? If I number it like this, 1, 2, 3, 4, the branch is present in the second carbon, right? So it should be 2-methyl
Two.
butane.
Okay, yeah.
Okay.
Two.
And then if there is a CH3 here again, how do I write it?
It will be dimethyl.
Is it
Two
only that?
dimethyl.
No, no, no. 2, comma 2. So both the methyls is present in the second carbon. So 2, comma 2 dimethyl butane. Okay. And if I have my CH3 in this, then
It will be two com two no
no,
2,3 dimethyl
yeah, dimethyl
butane.
butane. Okay.
Butane.
Now I'll just write it like this: CH2, CH3. Now, so a branch like that. You will not get it. I don't think you'll get it. But again, then you should go with this. Okay. You should write 2-methyl and then 3. What's this? What's this branch? 2 carbons. Ethyl, right? Meth. So ethyl
Yeah.
butane. Understood? So you write the two branch separately because it's two different branch. Here both are methyl, right? So I can just go with dimethyl. Okay. And
Yeah.
if there is a okay something like this. How many bonds can carbon make?
Four.
Okay. Now okay, can you tell me this?
Okay, it's two methyl one in.
But
One in.
okay. How can it be 1 in? If you're saying 2, you're numbering in this direction, right? So this
Okay,
should
then
be
it's
the
four in.
Is it 4 or 3, dear? You should get the lowest number.
Oh, three, three.
3, right? So 2-methyl but 3 but hyphen 3 ene. Understood?
Yeah.
Okay, go with the lowest number, and then first, whenever you get a molecule, number it. Use your pencil or pen, like number it, and then do it. Don't just write the answer. And then if it is alcohol, it ends with an OL, okay? OL. Like alkane ends with ANE, alkene ends with ENE, and then alcohols end with OL. Okay, what do you think carboxylic acids will end with?
Pardon?
What do you think the carboxylic acid compounds will end with? Now, alkanes, the name ends with AN, alkenes ENE, alcohols OL. So, carboxylic acids, what do you think?
OL. OL.
OL is for alcohols, no? Propanol, methanol, ethanol.
I'm not sure about
It
carboxylic
goes as
acid.
oic acids, okay? So methanoic acid, ethanoic acid. We'll look at
Oh,
those.
ethanoic. Okay, yeah.
Okay, it goes like that. Okay, so we looked at that. Naming the compounds. And then what are alkanes? Alkanes, can you define them?
Alkanes.
Yes.
Alkanes are saturated compounds. They have
Okay.
single bonds
What
between
single bonds?
carbon-carbon
Yeah, don't just
atoms.
write single bonds. They will ask for definition. So you should write alkanes are compounds which contain carbon-carbon single bonds in them, and any compounds which contain carbon-carbon single bond in them, then we call them as saturated compounds. And then alkenes, they are unsaturated compounds, okay, because they have double bonds, carbon-carbon double bonds. And then we looked at some examples like methane, ethane, prop, bute, and pent. Like meth is 1, eth 2, prop 3 carbons, bute 4, and pent 5. Okay, and then okay, so all the alkanes, they have a same functional group, that is carbon carbon single bond. They show similar chemical properties because all the alkanes have the same functional group. Okay, and then they show
Yeah.
a trend in physical properties. Can you tell me an example, like what about their boiling point of alkanes? How does it vary?
The
Boiling.
boiling point is high.
Okay, how does it change?
The more is it because the more molecular mass,
Okay, now
the
if I
higher the boiling point.
compare CH4 and then this propane, which one will have a high molecular, high boiling point?
Propane,
Propane.
propane.
That is because when the number of carbon atoms increases, like carbon and hydrogen, all that, the molecular mass increase. So when the molecular mass increase, the intermolecular forces increase, become stronger. So more energy has to be provided to break the strong intermolecular bond. So the boiling point increases. Okay, the same answer. Whenever they talk about, ask us about melting boiling point, it's the same. Okay. Then they have the same general formula. What is the general formula for alkanes?
CN H2N
No, that is for alkenes.
plus
Plus 2,
plus two.
okay? And alkenes goes as CnH2n, okay? We'll learn that today.
Yeah.
Don't get, okay. So the N is the number of carbon atoms. Next, about the chemical properties, they are inert. Why do I say they are inert or they are fairly unreactive compounds? All the alkanes. When we compare
They have a
alkane
full
and
outer shell.
no, that's not the reason. Even in alkanes, they have a full outermost shell. Anything will have a full outermost shell. No, the HCl is also because when they share, they become full outer shell.
Ah,
Now
okay.
here it's saturated, right? So single bonds, there's nothing to
Yeah.
happen here. But now when we consider alkenes, there is a double bond. So there is a tendency for this bond to break. So they are more reactive than this, okay? And now I said there are some compounds with triple bonds in between. They will be more reactive than alkenes also because they like react fast, okay? Because of their triple bond. Just know that, not in your syllabus. Okay. Now, did you put the topic reactions of alkanes? We'll start with that today. So just like we studied inorganic compounds, are you here? Okay. I'm just waiting till you unmute. Okay, I'm just typing alkene show two types of. Did I give you the note for this combustion? I think, or I just explained it to you.
No, you only told me the both of the types,
Ah, okay.
complete and incomplete
Okay.
as well.
Now, can you remember? Okay, what are halogens?
Group 7.
Group 7. What do you mean by halogens? The meaning? Means salt forming, right? Can remember when they react with hydrogen like H2 and Cl2, it formed hydrogen halide, HCl. H2 and F2, it formed HF. Okay. It formed hydrogen halides. That was one reaction where what we studied under halogens. And then can you remember we learned about HCl gas turning to HCl acid when we dissolve it in water. Okay, that was
Yeah.
the second type. And then we studied something called displacement reaction. The more reactive element will displace the less reactive one. In group 7, can fluorine, chlorine, bromine, iodine. Who is more reactive here?
Uh, Fluorine.
Chlorine, okay. So if I have HF, HCl and F2, then it will be HF plus Cl2. Okay. The more reactive one will displace the less reactive one. So that was one type of reaction what we studied. So see different types of reactions when it comes to halogens. The same thing we are going to do it in organic chemistry. Okay. We'll study what alkanes are and then we'll just study the reactions what they undergo. Like in alkanes, it's just only two, combustion and substitution. Alkenes again just the type of reactions what they undergo some okay, and then again the same thing with carboxylic acids and all that. That's the outline of the whole organic chemistry, your O level syllabus. Okay, and then sometimes in some lessons we will see how we can produce these alkanes in the lab. Like we learnt about carbon dioxide, there were two methods. Can you tell me two methods to produce carbon dioxide in lab?
It was thermal decomposition of carbonates and
Okay,
adding HCl to dilute HCl.
dilute HCl to calcium carbonate, right? Or any carbonate,
Yeah.
no? Yeah. Thermal
Yeah.
decomposition adding dilutes. Okay, what color is copper carbonate?
White.
No, that was barium sulfate. Copper carbonate?
Was it green?
Yes, it is green. Okay, copper carbonate, green. Good. Okay, so reactions of alkanes, they show two reactions. We have combustion and substitution. Combustion means just anything burning in oxygen. Now, when there's an adequate amount of oxygen, it undergoes complete combustion, and then we will have carbon dioxide and water as the products. Okay, when there is inadequate amount of oxygen, then it will undergo incomplete
It
combustion.
was incomplete.
Yes, then it produces carbon monoxide and water, or else carbon and water. So there is two reactions that can occur. We already always say that the incomplete combustion produces carbon monoxide and water, right? But sometimes there can also be carbon and water. Okay, carbon is that black soot whatever forms at the end of any burning reaction. So then if we see that soot forming, then we know, okay, the incomplete combustion has taken place. When it is complete combustion, the soot won't form. Okay, clear? Shall we write it down?
Yeah.
Okay,
Yeah.
so complete combustion. Okay, and then we'll write an example. So CH4 plus oxygen. Know the physical states. Always water goes with liquid, all others gas. Now see alkanes also gases. Why? We learnt it in under physical states. Can remember the first five goes as gas, and then only when we go to C18H something here, then it goes to the solid state. Okay, all the first few alkanes, all are gases in our syllabus. And then you should know
Miss,
to
is that
balance the,
CH4?
yeah, CH4. And then you should know to balance the equation if they ask you to write the chemical equation. Then C2H6 plus O2 can give carbon monoxide and water, or can give carbon and water. So here the carbon is solid. Okay.
Miss, isn't it CO2?
Which one, dear? The second reaction.
First reaction,
Yes, it's
if it's a
CO2.
gas.
Yeah, it's CO2. Okay. Is it clear? Shall I type it?
Yeah, it's clear.
Okay. If you're studying with my note or your school note, just memorize all the reactions. If you're taking a short note, you can just have one A4 sheet for alkanes. Just write the two reactions and another page for alkenes. It will be only maximum 2 to 3 reactions under each organic compound group. Okay. So have a short note like that.
Listen, that B, the first reaction, is that C2H something?
6.
6, okay. Miss, in the B's first reaction, shouldn't it be CO2?
It's incomplete combustion, no dear. So it will form carbon monoxide or carbon. Carbon dioxide will form only when it's complete combustion.
Isn't carbon monoxide CO3?
CO3 is carbonate, the ion.
Oh, okay.
Okay.
Okay, I'm done.
You can just take it down. CO is carbon monoxide, capital C, capital O. Okay. CO2 carbon dioxide, CO3 2 minus. You go with the charge on top, then that is an ion. Okay. Ions are anything which contains a positive charge or negative charge on top. So that is carbonate. And then we can write carbonates for any metal, right? Sodium and carbonate. How do I write it? 1 and 2, I cross it. I write Na2CO3. Okay.
Yeah.
Likewise. Now the second type of reaction is substitution reaction.
What's the charge of CO3?
2 minus. So it goes as 2.
And it's a carbonate.
Yeah.
Okay, I'm done.
CO3, 2 minus. So it's carbonate. What is this? Ion.
Sulfate.
Sulfate. Okay. Again, that also has 2. Ammonium, NH4. What is the charge?
2 plus.
No, it's just plus. Ammonium is plus. Okay.
Oh,
Revise. We are almost done. Yeah, that's it. Yeah. How can we identify ammonium containing compounds? Tell me if it's
by
ammonium containing
adding
salts.
by adding uh,
if it's NH4Cl, I want to identify if this is an ammonium containing salt in my beaker. What do I do? Ammonium means NH4 ions. How do I identify NH4 ions? Now this is a positive
Adding
ion.
damp red litmus paper.
No, before that we do something. We add a
You
damp
add
litmus paper, it turns blue. That
dilute HCl.
no. For positive ions, can remember what are the tests we have. Now I'm going to revise it. So it's positive ions. What are the tests we have? We have the flame test, right?
Yeah,
And then what was the other test? Testing positive ions with what? We add what? We added sodium hydroxide, no?
yeah.
And then FeOH, if it was Fe2 plus, it formed FeOH2. What was the color?
FeOH2 is it was green
Green, okay. Fe3 plus,
and then brown.
red brown, orange brown. There was not, can't be just brown.
Oh, red brown.
Orange, okay, I can't remember. See if it's orange brown or red brown. Copper hydroxide is blue.
Yeah.
Okay, and then now ammonium ions. How did we check it? Now all the other positive ions, we do the flame test and then that color. Here for all these ions, we just add sodium hydroxide and then that will give the precipitate. These colored precipitates, we can identify it. Ammonium, what did we do? When we add NH4Cl to ammonium containing salts, mhm.
Did we have to have barium chloride?
No, check your note and tell me how to test for ammonium ions. Barium chloride is for sulfate. Eh, always for sulfate. And it will form barium sulfate, a white precipitate. We have only a few months more. You should revise after doing all these classes if you don't get good results. Okay. NH4Cl plus NaOH will give what?
NH3
Yeah,
gas.
ammonia
And
gas.
then you can test that with damp red litmus
Damp
paper.
litmus paper. And then if it turns blue, we can confirm that the mixture contains ammonium ions. Okay.
Yeah.
So all the positive ions, if your question is about positive ions, just it will be the flame test or adding it to sodium hydroxide and the colors, okay? And then if it's ammonium ions, then the release of ammonia gas. You should like revise it and then you should study. Okay, next put the topic substitution reaction. Now exam is closed. I'll be asking questions here and there from the syllabus. Revise it every day. Okay, substitution reactions of alkanes. So just like the name says, one hydrogen gets replaced by halogens. Okay, now normally this is an alkane with halogen reaction. Okay, write this. Okay, I'll just go with an example first. So see, don't draw it. I have an alkane, H hydrogen, and then if I add bromine, so this is a halogen, right? How will this look? This is bonded like this. Understood this point? So the bromine here would look like this, right? Bonded with a
Yeah.
covalent bond in between. Okay, two bromine atoms. Now, in the presence of UV radiation, okay, only in the presence of light, this reaction will happen. In the absence of light, this won't happen, okay? So that's a must here. In the presence of UV radiation, one of this hydrogen, it can be any hydrogen, one of this hydrogen gets replaced or substituted by this bromine. So it becomes CBr H and H, and then the other bromine and this hydrogen is left right now. See,
HBr.
yeah, it becomes HBr. Clear? Now, can you name this compound? What do you think how to name this?
CH3Br.
Okay, naming it, not the chemical formula. Bromo
Mm,
methane, okay? By one carbon, it's an alkane. See, it's an alkane, one carbon, so meth, and then the branch here is bromo, bromine, right? So it goes as bromo. If it's chlorine, chloro, likewise, okay? In brackets.
yeah.
Now this is in the presence of UV radiation. Okay, take this down. Okay, now if I write this in the formula way, so it is like the CH4 plus Br2 becomes CH3Br, writing the condensed formula, okay, plus HBr. So all gases here. And now because one hydrogen is substituted, I can call this as a mono substitution reaction, okay? There are instances where two hydrogens can be substituted, not for your O levels, not in your syllabus, okay? Which lesson are you doing in school?
Titration.
Titration. Oh, so still inorganic, and then okay.
We did it in mixed up orders.
Uh-huh. When will you have your final mock? Before that, will you have
Yeah.
any term test?
Uh, I I'll have like class tests, but
Uh-huh.
I won't have a practice mock. So yeah.
Okay. Are you done?
I'm writing down the equation, the condensed. Okay, I'm done.
Okay, now can you do it for this molecule compound here? So just a second example, okay? And then you can write the condensed reaction for this.
Is this in presence of UV?
Yes.
This is uh, ethyl chloride.
We should
No,
name the
chloro eth- ethane.
chloroethane. Okay, the branch comes first, and then you can substitute any hydrogen there. Okay, I'll just take this off. So all others hydrogens plus what? HCl. So if this is a
Yeah.
gas, all these are gas. So how do I name this HCl in gaseous form? Is it
Sorry.
now? What is the name of this compound?
Hydrochloric acid.
Hydrochloric acid is HCl in aqueous. Now this is HCl in
Hydrogen
gaseous.
chloride.
Hydrogen chloride.
Hydrogen chloride.
Yeah, take it down. So this is hydrogen chloride. Now in your paper, you should see if they're asking the name of the compound, the chemical formula, or the structure and all that. Okay.
Yeah.
Yeah, hydrogen chloride there, and this should be methane, right? This is ethane. And you can write the condensed if you
Ethane.
want.
Yeah.
Yeah.
Okay, I'm done.
Again, take down this point. Alkenes react with halogens.
Okay, Miss Sandha.
Okay. So one more point here. See this example. If propane is if propane undergoes this substitution reaction, we'll just take C, all hydrogens here. So if I react with this bromine, now the bromine can go and replace the first carbon or the second carbon, right? So if it replaces the first carbon, I should write it as 1 bromopropane. If it is the second carbon, 2 bromopropane. Okay? Or
Yeah.
if it's okay, again, if it has replaced this, then how do I write it?
Um, if what has replaced which?
Okay, this this is if the bromine has been in the first carbon, 1 bromopropane. If it has replaced
Yeah,
the second
then
hydrogen, 2. Now if I just draw the bromine on my third
it's
carbon, this
one.
carbon,
It's
it's again
one.
1, okay? 1 bromopropane because the branch gets the lowest number. Clear?
Yeah.
So
Yeah.
see, sometimes more than one molecule can also be formed. So your answer can be different. Then we call it now. See, it's the same formula. If I write it, it is going to be CH. mm, okay, CH2Br, CH2 and CH3, right? So it's the same thing here too. Okay. If I just write all together, the molecular formula C3H1, 2, 3, 4, 5, 6, 7. CH C3H7Br. If I write the molecular formula for this compound, for this, is this correct? For this compound A, the molecular formula is this, no? Showing the actual number of atoms
Uh,
present.
yeah, that's
Okay,
correct.
and then even for B, see, it's the same formula,
Yeah.
but the structure is different. Do you see that? So when they
Same
have
same molecular formula, but
oh
different condensed
structure,
formula.
yeah, we can tell it as structural formula, okay? Because the condensed formula will be also different. The displayed formula also will be different, right? Both comes under
Yeah.
structural formula, right? So molecules like this, we call them isomers. Now, last class I did not teach you what isomers are. These are called structural isomers. The structure is different, but the molecule is the same. The molecular formula is the same. Okay, these are
Yeah.
isomers. Ah. So see, when propane reacts with bromine, it is possible to form two products, and then they are isomers. Okay, they are structural isomers because they have same molecular formula but different structural formula. Clear up to this?
Yeah.
Okay, that's it about alkanes. Do you have any questions in alkanes?
No.
Shall we move to alkenes? Okay,
Yeah,
put
sure.
the topic alkenes. So what are alkenes? Alkenes are carbon-carbon double bond containing compounds. Okay. Are you done?
Yeah.
Okay, so alkenes, they contain carbon-carbon double bond, and then what is the functional group of alkenes then?
They're unsaturated
Okay.
hydrocarbons.
Yes, good. They are unsaturated. Now tell me what is the functional group of alkenes?
Uh, double uh, bonds.
What double bond here? Carbon-carbon double bond, okay?
Carbon, carbon.
Now
Yeah.
sometimes there can be a double bond even in between carbon and oxygen, but this doesn't make it a alkene. The alkene should have the double bond in between carbon-carbon, okay?
Yeah.
And then here these are some examples. ethene, propene, but1-ene. It can also be but2-ene, but3-ene. Are you okay with all this? Just go through the table and the names.
Yeah, I'm okay with that.
Okay. And then they are unsaturated compounds because they have double bonds. And this is the general formula, okay? CnH2n. Okay,
Miss,
and they are
is there a possibility of triple bonds in
triple,
hydrocarbons?
yes. We have a totally different group, just like alkanes. There's something called alkynes. Okay, so they have carbon-carbon triple bonds. It will, now if I just draw the simplest one, it will have two carbons with triple bond, and now this carbon should make four bonds, right? One, two, three. The fourth one can have a hydrogen. So this one, two, three, and now four. Understood? And it can have any
Yeah,
other bonds also, like C, the triple bond C, and then this can be a CH3. Okay, this can be CH2,
yeah,
CH3, anything. These are another group of organic compounds, alkynes. We write it, okay. Okay, clear?
yeah.
Okay. Now they also have a general formula and all that. Not necessary now. Okay, so the general formula of alkenes is CnH2n. N is the number of carbon atoms present. And physical properties, again similar to alkanes. And then all alkenes, they are going to show similar chemical properties. Now think like this: if this alkene reacts with oxygen, this also will react. This also it will show the same reaction because they contain the same functional group. When an organic compound contains the same functional group, they are going to show similar chemical properties. And then again, their physical properties will show a trend, like the melting point and boiling point. When the molecular mass increases, the boiling point will increase because the intermolecular forces increase, right? The strength of the intermolecular force increase, so the number of so more energy has to be provided to break the bonds. It's the same thing like
Yeah.
alkanes, okay? Now these are the chemical reactions of alkenes. What we'll study first is combustion. We are familiar with that. Again, the same thing. Alkenes can undergo complete combustion and incomplete combustion. If it's complete combustion, the products are going to be carbon dioxide and water. If it's incomplete, carbon monoxide and water, or else what?
Soot?
Soot,
No,
carbon and water.
carbon and water.
Yeah, or you can say soot. Okay, carbon and water. So then the second type of reactions is addition reaction. We'll see what addition is. And then we have something called hydration. Three types, okay? So hydration, from the term, what can you say? Hydrated or hydrate. What is it? It reacts with water, okay? So a double
Yeah.
bond containing compound reacting with water. And then uh, what happens is this bond breaks and then the OH in this water is added. So see, it becomes an alcohol. Got an outline of the lesson? Shall we take it down? Like we'll write it.
So it's what's the subtopic?
First, just write these points under alkenes. Okay. And then you can write their general formula. So if you want, you can write an example. If n equals 5, then the molecular formula will be C5H2 into 5, C5H10. Okay. And then I'll write the other points here. Alkanes are Now, about the reactivity of alkenes. Who are more reactive? Is it alkanes or alkenes?
It's the alkenes. Is then are alkynes also unsaturated?
Yes, they are also unsaturated.
Okay, I'm done.
Okay, now put the subtopic chemical reactions of alkenes. So they undergo three types of reactions. We have combustion,
Is there no titration in alkenes?
a titration. No. Why do we do titration?
I heard you say titration before.
No, it's hydration. Okay, not titration. Titration is between an acid and a base to find out how much of acid or a base is needed to form salt. Okay, it's hydration, reacting with water, hydra.
Yeah, okay. I'm
Okay,
done.
now okay, first subtopic combustion. Again, the same thing. I'll just give you this example. Can you draw the displayed formula for this? C2H4. Now, this is a alkene, okay? Can you just draw the displayed formula for only this compound? Liquid.
Like displayed.
Yes.
Miss, carbon dioxide has double bonds, right? Between the oxygen and carbon.
Yes. Okay, what color is bromine?
Okay, I'm done.
Aqueous.
Bromine
Bromine gas
aqueous.
is brown, right?
Yeah.
So aqueous.
It's still brown,
No, orange, okay?
blackish brown, or orange.
Orange, orange. Okay, are you done with this? How did you draw C2H4? Can you send me? Okay. Did you draw it with a double bond? So two carbons, right? But I know this is an alkene, so I put a double bond in between. Okay? Did you do it like that? No. Did you draw C2H4 like this?
Yeah, I did.
Ah, okay. So
I'll
it's
send you my picture.
no, it's okay. That was correct, no? Understood?
Yeah, yeah.
Okay. Now the second type of reaction of alkene, so addition. So addition, just like the name says, we'll see the double bond breaks and then the halogen gets added. Again, here too, just like the substitution reaction, the alkenes also react with halogens, but they no need the presence of any like heat, light, or any catalyst. Okay. In the previous reaction, what we learned, alkanes, for them to undergo substitution reaction, UV light has to be present. No, if not, the reaction will not proceed. But here, addition reaction, they no need UV light, heat, or catalyst or anything. They, if I just add an alkene and a halogen, they are just going to react. Okay, clear? No.
Yeah, Miss, I understood.
Okay, now I'll just draw. We'll see an example. Now we'll see alkene like this. C double bond C. I react it with bromine. So it's addition reaction. What happens is the double bond break here. Now this is bond one. Okay. This is the second bond. Think this as a stick. Okay. And then think this breaks. So what will happen? I will have
One
just
bond.
here, no, one here and one here. No, two bonds. Do you get it? Like one, when one stick breaks into two, I will have just place for something two to get bonded. Understood? So
Yeah,
this breaks and now I will have these two like this was already present now. Now the bond what breaks into two. Okay. The stick here breaks into two. One goes here, one goes here. Clear?
yeah,
Now the stick means like what is this? What does this one straight line in the bond represent in the structure? What is this? What does this line represent? It's a pair of electron, no? There is electron here and there is electron here,
yeah,
okay? So when this break, one electron is here and the other electron goes here, like from this position, from the second bond, okay? So what happens? The hydrogen can go and share. Clear?
yeah,
You need not know all that, but again, that's the theory. Yeah. Okay. So it becomes, sorry, not HH. It becomes BR, okay? The two bromine here gets added. And then this will be the only product. Understood?
yeah.
Okay. Now if I want to name, label my compound, how can I label this? If you want, you can just draw like this breaking. Or you can just write if you have understood, that's okay. Tell me, what's this? If I just label this as 1 and 2, now wait. And then now label this. First, we should name the branch. So can you tell me the branch? What is the branch here?
Uh,
Try it on your own, don't check it.
where, where, which branch?
Now I want you to label this compound.
Oh, okay. It's uh, boro. No,
Bromo,
bromo. Uh, bromoethane.
bromoethane. Okay, now just see if they ask us to draw bromoethane, how are we going to draw it? eth means 2 carbons, ane is alkane, and then bromo means 1 bromine, right? This is how we'll draw it. Is it correct? What am I missing? Now when they say
Where?
bromo, I'm just going to draw only 1 bromine. So now here this has 2
So it's
bromines.
two bromo.
We don't say 2 dibromo, na?
Bro. Oh, dibromo.
Dibromo. And now I should also, but now even if, though I know it has dibromo, I don't know if I should put both my bromines in 1 carbon or in the second carbon and the first carbon. So you should be specific with that also. How do I, what's my mistake here then? Dibromo, methane, okay, but dibro
Dibromo.
ethane.
Uh,
Now
one
say,
one ethane and then two ethane.
so 1 comma 2 dibromo ethane. Okay.
Yeah.
Can remember like when we had this with the CH3 here, we wrote it as di 2 comma 2 dimethyl. Okay, remember the examples and just relate it to the question. Are you clear with how we name this compound
Yeah.
here? Oh,
Yeah.
okay, write it down.
Miss, does the bond break and become single bond?
Yes, the double bond breaks and becomes single bond. Okay. First we had double bond here. Now it's a single bond. The bond what is broken is here. Bonds with bromine. So if I write the condensed formula, yeah, I can write it as CH2, CH2 plus Br2 becomes CH2Br, CH2Br. Okay.
Yeah. Okay, Miss, I'm done. Miss, what's the state symbols?
State symbol again all gas. Wait. Ethene is a gas, bromine aqueous. This is aqueous. This is a gas. Now when I mix a gas with aqueous, go with liquid here.
Liquid?
Yes.
Why? Isn't H2O and
Only
ethanol only the
ethanol, only
liquids?
liquid. No, but here again the textbook goes as liquid. Go with liquid. Yeah, it says solution, but again the physical state says it's liquid. Now what can we observe here? Observation. See the bromine. We now if I
Fission? Fission?
fizzing comes when there is a gas produced, no dear.
Oh, okay, then no gas produced, so no fission.
Only
Color
when the
change?
gas is in the color change, okay? Only when the gas is in the product side, write fizzing. Now this is in the reactant side, so don't write fizzing. Ah, okay.
Yeah,
Okay, now we will have bromine solution inside this. So that would be a orange solution.
orange.
But when I bubble in CH2, here what will happen? The color will change. So orange aqueous solution turns to colorless. You can write it.
Yeah.
I'll clear all this.
So it goes from orange to colorless.
Yes. Observation. Orange bromine solution turns colorless.
Okay.
And take this down. Next point. Why do you think it will not require any heat, light, or catalyst? Because alkenes are more reactive than alkanes. Okay, so they just react. When it comes to alkanes, we have to give them that UV light for them to react because they are non-reactive compounds.
Okay, I'm done.
Okay, that's about addition reaction. And now the third type, hydration reaction of alkenes. Again, it's something like addition. The double bond breaks, but here it's not about halogens, right? So we'll see. So C double bond C with water. Okay. Now what happens is the bond breaks here again. So carbon again can form, it becomes single bond. So it becomes, it will have all the hydrogen and then one O and one H is formed. So an alcohol is formed, okay? So if this one bond breaks, it should form two bonds, right? Two new bonds. So this is the bond that forms. Okay, clear? So this whole thing,
Yeah.
like OH from water comes there. In the previous one, BR, these two are the new bonds formed. Here it's these two, okay? Clear?
Yeah.
Ah. So see, OH containing group. So what is this? Is this an alkene, alcohol, carboxylic acid? What is it?
It's alcohol.
Alcohol. Now see, if I want to prepare alcohol in lab, I can just react an alkene with water and then I will get alcohol. You get
Is
it?
it consumable alcohol?
Alcohol, this alcohol. Yeah, if it is ethanol, ethanol is poisonous. No, 100% ethanol is poisonous. Okay. Okay, now here this has conditions. So temperature should be memorize this, 300 degrees Celsius. Pressure should be 60 to 70 atmospheric pressure and
This
then
is
catalyst.
needed for hydration reactions to occur, 300
Yes.
degrees.
Yeah.
But wouldn't the water evaporate?
No, because we are mixing it with the organic compound. No, it's not only just separate water. We are reacting it, so that's okay. Pressure, memorize these values. They'll ask you 60 to 70. Catalyst here is phosphoric acid. When we study about alcohols, we will learn like just like carbon dioxide had two methods to prepare carbon dioxide in lab. So now if they ask you a method to prepare alcohol in lab, see now you know it, okay? We can react any alkene with water, we will get an alcohol, okay?
Yeah. Yeah.
Okay, what is the name of this compound?
That's methanol.
Meth is one carbon.
Oh, ethanol.
Ethanol, yeah. This reaction is used for the production of high purity ethanol in industry. Okay, we'll learn about this in detail later.
Okay, I'm done.
Okay, we'll write down these points under the same topic. So
Okay, Miss, I'm done.
okay, that's it about the reactions of alkenes. Any questions up to this?
No.
Okay, can you send me a pic? Your reactions of alkenes?
Yeah, sure. From the start of the note we made today?
No, just send me alkenes, alkene reactions.
There you go.
Okay, I'll check. Yeah, you can take this down. So we have a test for unsaturated compounds. Now, just like we have tests to identify carbon dioxide, oxygen, chlorine, ammonia, and then all the positive ions and negative ions. Now, this is a test to identify if the compound. The sample what they have given is a unsaturated compound or unsaturated compound, okay? So
Yeah.
unsaturated means if it contains double carbon-carbon double bond, or if it is an alkane.
Okay. Yeah.
I'll explain it, write it down. Okay, listen for a minute. Okay. So now to test for unsaturated compounds means if we should test if our sample contains carbon-carbon double bond in them. We know when a double bond containing compound reacts with bromine water, it undergoes addition reaction. And what is the observation we can see? Now
Uh,
bromine water is
the
orange.
the color change. It
Yeah, the
goes from
color
orange
change,
to
right?
colorless.
Colorless, right? So it goes from orange to colorless. Now, is this in the presence of UV or in the absence?
Absence.
Absence. Okay. Now just think I have an now think my sample has alkane, uh, not a double bond containing compound. Then if I react it with bromine, will this reaction occur? Now I'm not,
Alkanes, no.
no, okay. But if I uh, provide UV,
Yeah.
what will happen? Is it addition reaction?
It it will work. Yeah.
Is it addition?
No, it's substitution.
It's substitution. Again, the color can change, but that is in the presence of UV, no? So here we
Yeah.
don't add UV. So then see, if you shake an unknown organic compound with bromine water and then the orange color decolorize, then it contains carbon-carbon double bond. But if it does not decolorize, then it contains only carbon-carbon. It does not contain a carbon-carbon double bond. Clear?
Yeah.
Now,
Clear.
here no reaction happens because I'm not giving UV, okay? If I give UV, there will be a reaction. That's different. But we don't give UV. If you want, you can take it down with the reaction. Yeah, better take it down with the reaction, no?
Yeah, I'm going to write it down.
At the hydrogens. So if they ask you how to test if a compound is unsaturated, this is the test you should write, okay?
Add bromine.
Yeah, add bromine water or aqueous bromine. Then we will, if the color changes from orange to colorless, then the sample contains unsaturated compounds.
Miss, can you give me 1 minute? I'll be right back.
Okay.
Okay, Miss, I'm done.
Yeah. Did you take this down?
Yeah.
So that's about test for um, unsaturated compounds. Okay. So I want you to, okay, just take this as a question. That's it. We are done with alkenes also. Okay. Okay. Just
Yeah.
I want you to write this reaction. C double bond C. Now what will happen to this bromine? Will it be a substitution reaction or an addition reaction?
Addition.
Why not a substitution?
Because substitution needs an alkane.
Okay, now here this is again alkane also no.
But there's a double bond C.
Okay, but that can't be the reason. What is the reason?
Uh,
For it for substitution
because
reaction occur, what's the requirement?
for substitution you need to have presence of UV.
UV, okay. So because this is without UV, you can just break this and write the addition reaction, okay? If it's
Yeah.
with UV, then there'll not be a question like that, but just know that, okay? Take it down. And then I want you to draw the product and name the compound. Send me a pic once done. So this is, and again, you can just name this also.
Miss, what should I put in the rectangles underneath?
Write the name of the compound.
Oh, okay. I'll send you the answer.
Okay. Okay, so the double bond breaks, and then we have two bromines there. Propene. Okay, propene is correct. 1, comma 2. Dibromopropane. Okay, now what's the mistake there? In 1, 2 dibromopropane.
Okay.
No, the name is correct. The writing. Where's the
It's
hyphen? Like after the number.
bromo.
No,
Okay.
no, no. It's 1, 2 dibromopropane. That's correct. But put a hyphen in between a number and alphabet. That's how you write the scientific name.
Oh, okay.
Okay, dibromopropane. If you don't put it, it's wrong. If this is not there, they can even, like, if it's a 1 mark question, they can just put wrong. Okay, make sure you write it clear.
Yeah.
Okay, that's it about alkenes. Any questions after that? Study. Understood? Alkenes, reactions of alkenes, and then how to produce alkenes, how to test for alkenes. That's what we looked at. Okay, so alkenes are double bond containing compounds. The reactions are combustion, addition, and what was the other type of reaction? Okay, so alkanes is done. Can you tell me what are the three types of reactions of alkene?
Yeah. Alkene. Hydration.
Okay, that is addition of water, which
Yeah.
will produce
Addition of water
alcohol.
and addition and
Yeah, addition. So that does not need the presence of UV. Okay, it can just undergo addition reaction, and then we had combustion. Okay, and then we looked at
yeah.
how
Combustion.
to make alkenes. Uh, no, how to test for unsaturated compounds. Okay, so that's this test. Clear? Do you have any questions in this section?
No.
Okay, can you do question 2? Write the answer and send me.
The decolorization is a test for double bonds alkenes, right? Test for
Yes.
alkenes.
Whenever the question says decolorizes bromine water, it's they're talking about alkenes, okay? So it should contain a CC double bond.
Displayed formula for hydrocarbon. So it's I can draw any hydrocarbon.
No. Read the question. See, a gaseous hydrocarbon P with 3 carbon atoms decolorized as bromine water.
Ah, okay, propene. Propene.
Yeah.
It's a condensed formula, right? For the part C
Yeah. No,
or
now it
display
says
or
you
displayed.
displayed formula.
Okay. Or balanced chemical equation. Okay. This addition and hydration are the same.
No, addition happens with halogens. Hydration is addition of water to form alcohol. Okay.
Yeah, okay. So addition reactions are when halogens react with alkanes in the presence of UV.
No, that is substitution. With alkanes, in the presence of UV, it will be substitution. Okay. If it's with alkenes, then addition.
Alkenes and halogens are added together.
Yes, that is only that is addition.
Yeah.
And then when we have alkenes and water, that is hydration.
UV isn't needed for addition, right? Of
Yes.
alkenes and
Yeah.
water. I mean, alkenes and halogens.
Yes. No need.
Substitution is where alkenes and halogens react in the presence of UV.
Yes. So hydrations, there are requirements. Okay. Temperature 300 degrees Celsius. The pressure 60 to 70. And the catalyst was phosphoric acid. Okay.
Yeah. I'm not.
Okay. Send your answers.
There.
Okay. If you want, you can take this down what we wrote now. These three: substitution, addition, and hydration. But again, we have written it. Okay, we'll check. Okay, so a gaseous hydrocarbon P. Now, you should read the description just like the inorganic questions with 3 carbon atoms. Now, it says with 3 carbon atoms, but we don't, okay. But we don't know if it's an alkane or alkene. Decolorizes bromine water. Always when something decolorizes bromine water, it is, you should know that they're talking about an alkene, okay? So that's correct. 1, 2, 3. Explain what the decolorization of the bromine water tests for. Testing for alkenes, not only alkenes. Right, it as testing for unsaturated hydrocarbons. Okay?
And unsaturated.
Yeah. Write the displayed formula, that's okay. This is also correct. Write a balanced chemical equation for the reaction between hydrocarbon and bromine. Okay. Now, using a displayed formula. It's balanced, right, already? Do you get it? It's already balanced. We don't need to add anything
Yeah.
like the numbers because we should just see the count the atoms. Okay, D1, the reaction between ethane and bromine gas in the presence of UV. Ethane and bromine in the presence of UV causes bromine to lose color. Now see again loses color, but only in the presence of UV, okay? If it is just
Yeah.
ethane and bromine reaction, then it will not lose color. Okay, now write a balanced chemical equation for this again. That is substitution. So you should only just substitute one bromine. The other bromine should go here. See, in this reaction, we added both the bromines.
Yeah.
This reaction is described as a substitution reaction, whereas the reaction between P and bromine is addition. Using the equations, explain the difference. Addition reactions are when alkenes and halogens. Read it.
Or added together.
While
I
substitution is where alkenes and halogens react in the presence of UV. Okay, so substitution is where hydrogen is replaced by a halogen. Write the word replaced. Okay, at this point.
okay.
And then addition reactions are when alkenes and halogens react together, and then like you should explain the whole reaction. The double bond breaks and the halogen is added to the compound. Okay, wait, I'll say you the answer for that.
For addition or
Addition. Now for substitution is where alkenes and halogens react with in the presence of UV. Okay, and then you should say hydrogen is replaced by halogen. Only then your answer is complete. Okay,
yeah.
or it's just like you're writing the question again. Addition reactions is when alkenes and halogens are added together, and then again you should finish it, saying the double bonds break and then bromine is added to the compound. Say just say what happens in the reaction.
Oh, okay. Okay, I
Take it
wrote
down.
that down.
Okay. So that's it about alkenes. Any questions about alkanes and alkenes?
No.
Okay. Now
No.
put the topic alcohols.
Okay.
Okay. Now alcohols again another organic compound. So carbon containing compound. And then what is the functional group of alcohols?
We have OH.
OH. Okay. So when something contains OH in it, then we call them as
It's
alcohols. And
alcohol.
then uh, So naming the compounds, it is like this. See, if it's with one carbon, methanol. Two carbons and OH, ethanol. Three carbons and OH, propan 1-ol or propan 2-ol, it depends. And then butan 1-ol. Okay. So see the molecular formula, we can just write it with the number of carbons, number of hydrogens, and number of oxygens. But structural condensed formula is different. Go through this table and see if you're okay.
Yeah, miss, I'm fine.
So I'm not giving you to write any examples. We'll move to the next. Okay. Okay, just write the
Yeah.
first point. All alcohols contain functional group OH bonded to the carbon chain. Done?
Yeah.
Okay. So we'll look at the reactions. Can you tell me the reactions what alkanes undergo?
Alkanes go on the substitution,
And
uh, combustion,
combustion. Alkenes
addition, and hydration. I
and
mean,
yeah, addition,
uh,
hydration, and one more.
and uh, hydration and where is it?
No, no, one more. We wrote it.
Combustion.
Combustion. Okay. See in the note what you're
Yeah.
sending, you have it. Chemical reactions of alkenes, combustion, addition, and hydration. Okay, just like that. Now reactions of alcohols, it's combustion, and then they undergo oxidation. What is oxidation? Your dog is barking. Oxidation.
Yeah.
That's
Yeah.
okay. It's okay. Oxidation. What's his name?
Agni.
Agni. Oh, nice name. Okay. Oxidation. What is oxidation?
Oxidation is when something gains oxygen.
Okay. Yeah. When something gains oxygen or loses electrons. Okay. So here
Yeah.
in this in organic, we learn it with respect to oxygen. Okay. So we'll see. Alcohol is going to gain an oxygen. That is oxidation reaction. But again, oxidation reaction can happen uh, in the presence of microbes, and then oxidation of alcohols can happen in the presence of chemical. reagents like potassium dichromate. Okay, just two different types of reaction. So oxidation in the presence of microbes. Take it down. And third, okay, we can add oxygen in two ways, in the presence of microbes and by heating with potassium dichromate. So these are the three reactions of alcohols. Combustion, again, it's the same. Complete combustion will give carbon dioxide and water, alcohol plus oxygen. So you can put the subtopic combustion, and then we'll just write an example. C2H5OH plus oxygen will give carbon dioxide and water. Okay, done.
No, not yet. Okay, I'm done.
Okay, then the second reaction, oxidation in the presence of microbes. Put the topic. Oxidation of alcohols in the presence of microbes. So it's like this. We'll just take ethanol. So C will have an OH group, right? And all others hydrogens. So this is two carbons, so eth, and then it's an alcohol, so ethanol. Okay, clear?
Yeah.
Ethanol in the presence of microbes. Now we don't write it in the reaction like this. Okay, I'll just put it. So bacteria, it can be bacteria or yeast in the presence of yeast or bacteria. If will undergo oxidation. So oxidation means addition of oxygen, right? So it becomes C, and
Yes, what does that say? B or bacteria?
bacteria or yeast, okay? And then it
Okay.
becomes two. The carbon doesn't change. The carbon number doesn't change. See, we should add another oxygen. So the hydrogen here is okay. One hydrogen, you can just replace it with an oxygen, but with a double bond. You can remember it like that. Okay, see, both of these hydrogens are removed. This and this. So we will have two bonds. That double bond is, uh, we put oxygen there. So it's carboxylic acid. See if you understood this. See, now this is alcohol, and now we have added an oxygen by removing two hydrogens. Still carbon makes four bonds. One, two, three, four. Now with the hydrogens itself, I can't add the oxygen here. Why? Then carbon cannot make five bonds, right? It can only make four bonds, okay? So we don't do that. We just
Yeah.
remove two hydrogens and add a double bond and then oxygen. So always remember it goes as a C double bond O and then OH. Now if something contains a C double bond O OH group, what is this compound then? We call it a
Carboxylic
carboxylic
acid.
acid. Carboxylic acid.
Yes, I have an appointment to get to, a braces appointment.
Ah, okay. Write it carboxylic acid and then just we'll finish with this. Then.
Yeah, I'm done.
Done. Okay, then we'll start
Yeah.
it next class.
Okay. Thank you,
Then
miss. Have a
bye.
good day.
Good night.
Bye.